Hi there, welcome to another video tutorial, and this time we are trying to do another problem on electronic configuration. In this case, we are now trying to look at an ion, okay? A specific form of your atom with charge. As you can see here, we have -2s, and this means it will have something to do with the number of valence electrons, or in general, it will affect the total number of electrons that we will be trying to distribute in trying to identify the electronic configuration of this ion. Okay, so as always, we start with determining the number of electrons in this species. So let's look at our periodic table. Alright, so let's locate oxygen, and oxygen is here. So it's element number 8, so that tells us that oxygen has 8 electrons in total. But remember, we are dealing with oxygen 2-, or the anion form of oxygen, so it means it has the number of electrons has been affected. So let's try to check. Alright, so as we have seen in the periodic table, oxygen, the neutral oxygen, has 8 electrons, but as you can see, it has a charge. It has gained a -2 charge, which means it has gained negatively charged particles, which are your electrons. So this tells us that it has gained 2 more electrons. Alright, so we now have +2 here, corresponding to this gained -2 charge, which means the neutral oxygen has gained 2 more electrons, having a total now of 10 electrons. So we now distribute these 10 electrons using the energy orbitals that we have seen earlier. Alright, so let's go back. Alright, so again, your N represents your number of shells, and we have your orbitals S, P, D, and F here. S being the lowest and F being the highest energy. So you go from here, then you go next 2p, 3s, then 3p, 4s, and so on and so forth. And on this side, you will see visually the difference of the energy levels using the orbital diagrams. Again, each box corresponds to an orbital which can accommodate only 2 or a pair of your electrons. Alright, so we have to remember that we have to distribute 10 electrons. So that's 1 here, then another 1. Okay, let me just draw that. Okay, so we now have again the orbital diagrams of represented by the different subshells corresponding energy, increasing energy. So as you can see, from 1s, 2s, 2p, 3s, 3p, 3d, then 4s, and so on and so forth. So we now try to distribute the 10 electrons that we have counted earlier. So I have drawn here already 1, then another 1, 2, so that's 2. Then we go to the next 3, 4. So remember, these are of opposite spins for it to be allowed in a single orbital. Then we have 3, 4, sorry, that's 5, 6, and 7. Alright, now why did we do it this way? Because we're following Hund's rule that it should be distributed first in degenerate orbitals, meaning orbitals of this approximately the same energy levels, before pairing up. So that's 7, 8, 9, oops, sorry, we'll do that again, 9, and 10. Alright, so we have 2 electrons in the 1s orbital, so that's 1s2, 2 electrons in the 2s orbital, so 2s2. Then we have 2, 4, 6 electrons in the 2p orbital, so that's 2p6. So let's write down our electronic configuration. Alright, so that was again 1s2, 2s2, 2p6. Alright, so let's check if you have the correct total number of valence, of electrons. We have again 10 electrons that we should have distributed. So that's 6 plus 2 plus 2, that's a total of 10. So this oxide anion, or oxygen 2-, has a total of 10 electrons. Now remember, the valence electrons are usually on the outermost shell. Now oxygen is actually on the group number 6 in your periodic table. If you look at periodic table, so this is group number 6, right? So that's 1, 2, 3, 4, 5, 6. So it means the neutral oxygen has a total of 6 valence electrons. Now if we go back, alright, so on the second shell, so that is the outermost shell, 2, 2, that's meaning on the second shell. Originally we should have 6 only valence electrons, but remember, this is an anion, meaning it gained 2 more electrons, so that's why we have a total of 8 valence electrons in this oxygen anion. Alright? So that's all for this. And thank you for listening and continue learning. Alright, but wait, before you go, let's check let's compare our answer to the electronic configuration of the oxygen on the Wikipedia. So as you can see here, we have again the core configuration helium that is equivalent to 1s2, 2s2, and 2p4. But remember, this is of the neutral oxygen, and what we did earlier was the oxide or the oxygen anion gaining 2 more electrons. So the 2p4 here should become 2p6. Alright? So that tells us that our answer is correct. So again, thank you for listening and continue learning.